Welcome back. This time we're looking at AB 2012 number 4. This one didn't show up on the BC test. It was only on the AB test that year. Part A is asking us to find the derivative of f of x. And we have the equation, so this is just really spot checking us to see if we know our derivative rules. Probably helpful to rewrite f of x first as 25 minus x squared to the 1/2. So it looks like for our derivative, first thing we're going to do is use the power rule. Drop that 1/2, leave the inside alone, lower the exponent by 1, and then the chain rule. We need to take the derivative of the inside, which is negative 2x. Clean that up a little bit. The 2's cancel, square root goes on the bottom, left with something like this. Though I'm sure you would still get full credit if you left that. I like this newer version of the answer though because it's going to help me in part B. But that's it for part A. The scoring guide says 2 points for this derivative. I'm guessing you get 1 point for if you did something like show the power rule, 1 point for if you also showed this chain rule and everything was correct. Part B asks us to find the equation of the tangent line at x equals negative 3. As we know, for an equation of a tangent line, we need a slope and we need a point. We're given the x value of the point. For the y value of the point, we go back to the original function, plug in negative 3. F of negative 3 would be square root of 25 minus 9. Square root of 16 is 4. For the slope, we go to our derivative, which we had to find in part A. It's not very common that you have to use a previous part in a new part, but we have to this time. If we put negative 3 into that, we get negative of negative 3, which is positive 3. 25 minus 9 square root would be square root of 16, which is 4. So our slope is positive 3 over 4. From there, it's easy mode. We just write our equation of the line. Y minus y1 equals slope x minus x1. Done. This was worth 2 points. Your first point came from getting this 3/4, which you would not have been able to get if you'd messed up on part A. If you messed up on part A and used that wrong equation, I'm not sure if they'd give you points. Seems like sometimes they say yes, sometimes they say no. And you got 1 point for your correct final answer. Had to be perfect. Could have got the y by itself, that part doesn't matter. You can leave it just like this though. That's the end of part B. Part C introduces a new function, g, and it tells us that g is equal to f of x for a certain interval, and g is equal to a different x, a different function for a different interval. Now we want to find out if g is continuous at x equals 3, negative 3, and it even gives us a clue to use the definition of continuity to explain our answer. So let's check that. Definition of continuity asks us for 3 things. Item number 1, f of negative 3 has to exist. So we check to see which formula that's going to go into. Because of the less than or equal to, we're going to plug negative 3 into this guy, which we already did in part B, and we got 4. And then it says the limit has to exist, but on this piecewise function, we have to check left limit and right limit. So let's take a look at that. Let's approach negative 3 from the right, which is going to be the bigger side. Negative 3 plus 7 is 4. We also have to look at the limit as x approaches negative 3 from the left. I'm writing f of x and I should have been writing g of x. I am deeply sorry. The left-hand side of negative 3 is going to use the top piece, which means we want f of negative 3, which we also know is 4. Therefore, the limit exists, the limit as x approaches negative 3. of g of x is equal to 4. So again, definition of continuity. Step 1, f of negative 3 exists. Check. Except it should have been g of negative 3. Still fixing my mistake. G of negative 3 exists. Yes. Limit as x approaches negative 3 of g of x exists. Yes. Are those two values equal to each other? In this case, yes. So our answer is this function continuous at x equals negative 3 is yes. Because the best because I can think of that really says what we need to say would be something like this. Limit as x approaches negative 3, g of x is equal to g of negative 3. Done. This was worth 2 points. 1 point comes from considering one-sided limits. So we had to see some evidence that you did this. And 1 point was from your answer. That's it. Part C is over. Part D is asking us to evaluate an integral that looks kind of like the original function that we saw, but not quite. But that's good because u substitution looks like it's going to work. We can say something like u equals 25 minus x squared. Du equals negative 2x dx. Move the constant. And x dx is exactly what we wanted to see. So we can now rewrite this integral. In place of x dx, we're going to put negative 1/2 du. In place of 25 minus x squared, we're going to put u to the 1/2. And I'm going to change my limits too. I don't want 0 and 5 anymore. If x is 0, then u would equal 25 minus 0 squared. U is 25. If x is 5, 25 minus 5 squared, 0. So now I don't have to go back to x's at all. Find my antiderivative, u to the 3/2 over 3/2 times negative 1/2. Evaluated from 25 to 0. It's going to give me negative 1/3 u to the 3/2 from 25 to 0. Now it's a matter of plugging in numbers. Keep it a little simpler. I'll keep the negative 1/3 on the outside. So 25 to the 3/2 really means square root of 25 cubed. 0 to the 3/2, that's going to be nice. 0 to any power is 0. So square root of 25 is 5. Cubed is 125. So it looks like we end up with negative 1/3 times 125 equals negative 125 over 3. Abort, caught myself on a mistake. I need to switch these guys. So I'm going to pause the video and fix that. What you might have caught yourself is I should have been plugging in the 0 first, then the 25. I fell into a common trap where I put the bigger number first, but in this case we don't want the bigger number first. We get positive 125 over 3, and this problem was worth 3 points. The way the scoring guide says, the points are handed out, 2 points for the antiderivative. I don't know if that means you have to do everything right on the antiderivative, or if they'll give you partial credit if you get partway through it. 3rd point comes from your answer. You probably have to have this exact answer to get that final point. Of course, this would be acceptable as well. You do not have to simplify arithmetic. And that's it for part D, and that's it for AB 2012 number 4. Until next